Dear students, now we are in the 10th part of the uh, wrist and hand complex, continuing from the ninth part. The flexor carpi ulnaris muscle, which we all earlier studied earlier in the chapter also, which is an important muscle in the flexing the wrist. Here, the flexor carpi ulnaris muscle envelops the pisiform bone, which is a sesamoid bone that increases the envelopment of the pisiform bone, increases the momentum of the flexor carpi ulnaris muscle for flexion. The flexor carpi ulnaris muscle can act on the hamate and the fifth metacarpal indirectly through the pisiform's length ligaments. So, because of the presence of the ligaments which are attached to pisiform to the hamate and the fifth metacarpal, this can the flexor carpi ulnaris muscle, when they are producing contraction, they can do flexion. Along with that, they can do ulnar deviation of the wrist complex. The flexor carpi ulnaris tendon crosses the wrist at a greater distance from the axis for wrist as well as ulnar and radial deviation. So the flexor carpi ulnaris tendon, which acts the muscle, because it has two functions. One is wrist flexion, one is ulnar deviation. So in ulnar deviation, the axis is different from the axis of wrist flexion in the joint. So here in both axes, when you see the position of flexor carpi ulnaris, the MA is more. So the momentum is more. So when the momentum is more, this muscle is able to produce more torque, more power. So this is useful. We can call it as this muscle, the CU muscle is a more stronger ulnar deviation muscle than if you compare this with the flexor carpi radialis. So the flexor carpi ulnaris muscle is a more effective ulnar deviation function than the FCR muscle in its radial deviation. If you comparing which is a stronger muscle, in one muscle is ulnar deviation muscle, one muscle is a radial deviation muscle. If you compare which is stronger, the ulnar deviator, the FCU, is stronger because it has a larger MA. The flexor carpi ulnaris muscle is able to exert the greatest tension of all the wrist muscles. When you take all the wrist muscles, the flexor carpi ulnaris has a largest ability to create largest tension, means largest torque, giving it particular functional relevance, especially with activities requiring high ulnar deviation forces such as chopping wood. So just in your hand now, students, just take your with your right hand, flex all your fingers, make a fist. Now make a fist and just imagine you are holding a big heavy hammer or something. Now when you hold itself and try to increase the power, you can see that the hand fist is going into ulnar deviation. This is because when you exert more pressure, the flexor carpi ulnaris is coming into play. So naturally, it is a flexor as well as ulnar deviator. So it will create that ulnar deviation. So the flexor carpi ulnaris muscle is a very important muscle in wrist flexion. Now going to the finger flexor. Now we have completed the three important primary muscles of the wrist flexion is completed. Now we have the other three, which are actually secondary wrist flexors. They are primarily flexors of the finger, which are the FDS, flexor digitorum superficialis, flexor digitorum profundus, and flexor pollicis longus, which is flexing the thumb. So predominant finger flexors and predominant flexor of the thumb, which is FDS, FDP, and FPL. So these three muscles are also having a secondary role in stabilizing the wrist joint as a multi-joint muscle. So these three muscles are a multi-joint muscle. Their capacity to produce an effective wrist flexion force depends on synergistic stabilization by the extensor muscles of the more distal joint that these muscles cross to prevent excessive shortening of the muscles over multiple joint. So here these muscles act as a synergistic muscle because the long muscles are coming and they are act, so they will prevent any kind of shortening of other multiple joint muscles. So they also have an important role to play in the wrist flexion. Now we will go into the, now we have completed the volar wrist musculature. We will go into the dorsal wrist musculature, mean extensor muscles. The dorsum of the wrist complex is crossed by tendons of 9 muscles. So in the volar area we have only 6 muscles, 3 muscles which are primary wrist flexors, 3 muscles which are primary finger flexors, secondary wrist flexors. In dorsal area we have 9 muscles. 3 of the 9 muscles are primary wrist muscles. Which are the 3 muscles? The ECRL, that is the extensor carpi radialis longus, and the extensor carpi radialis brevis, and the extensor carpi ulnaris. These 3 muscles, the extensor carpi radialis longus, the extensor carpi radialis brevis, and the extensor carpi ulnaris, is these 3 muscles are primary wrist extensor muscles. So now we left this 6 muscles. So other 6 muscles of the extensor compartment, or the what we call as a dorsal wrist musculature, all are finger muscles. They are going to each digits of the hand in, and their aim is to extend. So here, dear students, you can see clearly the picture. See the dorsal musculature showing, clearly all the area. Here this is towards the thumb. So you can see the APL, which is abductor pollicis longus. Then you have the extensor EPB, extensor pollicis brevis, extensor carpi radialis longus, extensor carpi radialis brevis, extensor pollicis longus, extensor indicis proprius, the index, you show the, your direction with your index finger, which is extension. In extensor in indicis proprius, extensor digitorum communis, which is a main important finger extensor muscle, strongest finger extensor digitorum communis. Extensor digitae minime, this is the extensor of the small finger digit minime. Then finally in the ulnar side, which is the extensor carpi ulnaris. So you have normally in the middlemost side, you have the, in the extensor compartment you have the extensor carpi ulnaris. Then naturally the middlemost muscle in the extensor compartment is a digitae, the small finger. So extensor digitae minime. Then you have the extensor communis, that is the extensor digitorum communis, which is to all they supply, this EDC will be supplying to all the 4 fingers. Then you have the indices. So index has a separate special, one single muscle for index, one single muscle for the little finger. Okay. And then then you have the extensor pollicis longus. Then you have the 2 radial muscles which are helpful in radial deviation, as well as extension of the radial side of the wrist joint. Okay. So this is the extensor. So already we discussed about that. Extensor carpi radialis longus, extensor carpi radialis brevis has already been discussed, because they are mainly, they are attaching to, their aim is not to the fingers. Their aim is, the attachment is only to the wrist joint. Same way extensor carpi ulnaris also. Here my dear students, you can see that here it is attached, finished. It attaches, does not go to the fingers. So extensor carpi ulnaris, one muscle already finished into the wrist joint. So in the 9 muscle, 3 muscles are primary wrist extensor muscle. Which are they? One is extensor carpi ulnaris. Here it is attaching. Then you have the extensor carpi radialis brevis, extensor carpi radialis longus. 2 muscles again attaching here. All the other muscles are going. So digitae minime going to small finger. Extensor digitorum communis, you see 2 tendons coming, one going into the 2 fingers, medial and medial to 2, and then to the lateral 2. Then you have the indices, which is going to the indices proprius, to the index finger. That is the first, to the just finger next to the index finger, that is thumb. Then you have the extensor pollicis longus, which is going to the thumb, which is from the medial to the lateral orientation. Then after that, in the last, the lateral most part is the abductor pollicis longus, which is a abductor muscle. So the other 6 muscles of the fingers are, and also the thumb muscle are EDC, extensor digitorum communis, which is the main muscle of extension of the fingers. Extensor indicis proprius, the extensor digitae minimi, the extensor pollicis longus, the extensor pollicis brevis, and the abductor pollicis longus. The extensor digitae, the digitorum communis, and the extensor indicis proprius muscles are also known as more as a extensor digitorum and the extensor indicis. Normally, when somebody says extensor digitorum means EDC, extensor indicis means extensor indicis proprius. So the tendons of all 9 muscles pass under the extensor. So same way we are talking about a flexor retinaculum. Here also we need a extensor retinaculum. Otherwise, what will happen? Bowstringing will happen. So the tendons of all the 9 muscles pass under the extensor retinaculum, which is divided into 6 tunnels by septa. Here again there are tunnels division inside the extensor retinaculum to form as tunnels, so that other tendons do not come and interfere in the action of a particular tendon. As a tendons as a tendon is encased within its own tendon sheath to prevent friction between, so preventing friction and to prevent any contact leading to friction is a main role of extensor retinaculum, which is separating the tendons into 6 septa, tunnels. The septa of the retinaculum through which the tendon pass are attached to the dorsal carpal ligaments. The septa of the retinaculum through which the tendons pass are attached to the dorsal carpal ligaments and help maintain stability of the extensor tendons on the dorsum. So it is maintaining, giving stability of the tendons of the dorsum, as well as allowing those muscles to contribute to wrist extension. So here the main aim of the tunnel, that is created by the extensor retinaculum, same like the flexor retinaculum, preventing bowstringing, prevention of friction due to contact by the tendons. And also here, because of the whole tendon and the septa and the tunnel, it gives a kind of stability, even though their main action is on the extension of the fingers. They will also have a power to stabilize the wrist joint in maintaining the stability of the wrist joint. So that is very, very important, right? The extensor carpi radialis longus and the extensor carpi radialis brevis muscle together make up the predominant part of the wrist extensor mass. I already told you that wrist extension mainly by 3 muscles are there: ECRL, ECRB, and ECU. So here in the two ECRL and ECRB makes a major bulk of our wrist extension mass. The ECRB muscle is somewhat smaller than the ECRL. Normally, longest muscle is larger than the other muscle, which is quite normal, but has a more central location. So ECRL has a more central location inserting into the third metacarpal and generally shows more activity during wrist extension activities.